Hello everyone, my name is Andrea, the BAZUKA Prophet. Greetings from Nigeria, Edo State, Benin City. Today we'll be working on a very interesting topic, talking about the glycoside and the glucoside. A lot of students have complained to me that they are finding it difficult to understand this mechanism and this topic on the board. That's why I'm making this video so that you can watch and share with your friends having issues too in a similar way. And today I'll be breaking it down by the grace of Almighty God. Now we start. Now, glycosides are, first of all, a glycoside and glucosides are not the same. Get that fact first. That a glucoside are the acetate obtained from glucose, meaning in the case of glucoside, it is just restricted to glucose. While in the case of glycoside, it is a general term for any carbohydrate reaction under this particular heading. So it can be any carbohydrate, any carbohydrate. Now, a glycoside or a glucoside are obtained. Take note, we are working basically on glucoside. So they are obtained when the anomeric hydroxyl group of monosaccharide, and this anomeric hydroxyl group can either be an hemi-ketal or an hemi-acetal. Take note. Now, previous video that we did, we've talked about it, so you can go watch it. Now, we have said that when that happens, it undergoes a condensation reaction in which water is eliminated, and that this particular anomeric hydroxyl group of monosaccharide is reacted with the hydroxyl group of a second molecule, so that in this case, under glucoside, we are making what we call the methyl alcohol, so that in the presence of an acidic solution in which the sugar in question is in, it will yield an alpha beta methyl glucoside. And I have told you earlier, this reaction is a reversible process or a reversible reaction. Now, the reaction scheme and mechanism is as follows, so you follow it very well. Now, for those of you who have not yet watched the video on how I treated how they draw this cyclic form of glucose, which is also called the Howard structure, please do well to go watch it. Do well to watch it. This is OH, this is H. This is H, this is OH, then this is what we call the OH, this is the anomeric carbon. Because the OH is down in the simplest form. If the OH is down, it will be called an alpha. But when the OH is not up, it will be called a beta. Or when these two are opposite, alpha. So you can call this one an alpha D glucose. You can also call it an alpha D glucopyranose, because glucose is a cis-membered ring plus a methyl alcohol or a methanol. So in the presence of a dilute HCl, what is formed? Please take note. The way the reaction scheme is, take note. Hydroxyl group we go combine with the hydrogen atom from this methyl alcohol. Now, we might not really want to go deeper here because of this reaction mechanism in deep sense and revelation is under what we call the nucleophile and the electrophile, which in our subsequent video we will take our time to treat it properly. Now, what happened? Water is formed. Now, remember, this reaction will yield an alpha beta form. So, what will happen when that happens? So, I'll be having, first of all, let's take note. Now, this hydrogen, this OH has already gone, plus this already out of it. So this one comes in. So I'll now be having OCH3. Everything remain intact. Now, we call this one a methyl alpha D glucoside plus, remember, H2O has already been formed, and again too, I have this one is OH, H, OH, then CH2OH. And remember, this one is called a methyl beta D glucoside. Yes, so this is what you tend to get. And remember that both this one is the solution. Both the alpha and the beta form of this glucose is what will react with this methanol in the presence of a dilute acid to give us the methyl alpha D glucoside and the methyl beta D glucoside. And that is what ends the topic for this particular video. For now, I remember my humble self and brotherly Bazooka Prophet. God bless you.